All right, so in the corner of my slide, it's labeled number 9, so I'm assuming that is it. All right, so I've changed my picture up here, and I want you to look at my picture of the heart. So we've got the 4 chambers of the heart, and we had said we're talking about coronary circulation. So I didn't bother putting the pulmonary trunk up there because it's actually on top of the aorta and would make it a little bit confusing. So I put just the aorta. And so this is the shape that the aorta takes, and it originates here in the left ventricle, right? And so we had said that you have coronary arteries that are going to be providing blood to all of the different parts of the heart. And so if we follow the left side first, so we're going to follow the left side first, and we have this diagram. So if you look on slide number 9, you see left coronary artery. And so we had said right at the base, right at the very base of the aorta, we have openings into the left and the right coronary arteries. And so right here, we're going to go to the left. So right here, as it's leaving the aorta, that would be the left coronary artery. Now, the left coronary artery is going to be providing blood to the front side of the heart. And so the left coronary artery branches very rapidly into the anterior interventricular artery, and that's going to go down the middle of the heart on the front side. But I said it branched, and so the anterior interventricular goes down the front of the heart, but then the rest of it is called the circumflex. And the circumflex artery is going to go over to the left side of the heart, and it's going to give rise to what we call the left marginal artery, which is going to go down the side of the heart. Now, it ends up, we have veins that carry the blood back up, but we're not going to be learning them. We're just going to say we have cardiac veins that are going to be carrying the stuff back up. So for the test, you need to know that the left coronary artery branches into the anterior interventricular and the circumflex, which then gives rise to the left marginal artery. And so if you say, okay, so what is being taken care of by the left coronary part of an artery system? It's going to be the front of the heart and the left side. So if we look at the right coronary artery, it is going to be circling around, and it looks a lot like the circumflex, but it is not, because the right is just the right. It's just the right coronary artery, and you notice that I have it going around back. It's going behind, and in addition, it's going to give rise to the right marginal artery. So it's going to take care of the right side of the heart, and we said it's going out back. And you know what? There is a posterior interventricular artery that goes down the back side of the heart. So the right side and posterior of the heart is provided blood by the right coronary artery, while the left coronary artery takes care of the front of the heart and the left side of the heart. And in all cases, we have veins that then carry the blood back up on the back side of the heart to a large vein called the coronary sinus, which returns the blood to the left atrium. Because again, what has it been doing? It's providing oxygen to the cardiac muscle cells. And that's all there is to it. Okay, so we have a picture of an angiogram, and this is where they've added an opaque coloring so that you can see where you might have a collapsed or a blocked artery. When a person builds up plaque, lipids, right? We always talk about your cholesterol. When that stuff builds up in the arteries, you can block an artery, and that's what a heart attack is. So a portion of the heart dies. Yeah, it's sad. Yeah, it's not good. No kidding. It sounds like I'm kidding, but I am definitely not kidding when I talk about that. Okay, so we have on slide 11, we can see some diagrams of the heart. And I'm going to flip this around so you can see what I'm talking about. What? It went backwards. Hang on. Here we go. So here we can see. Now I want you to notice that on this heart diagram here, you notice that the bottom of the heart is kind of swollen up. And we had said that what happens is the two atria pump blood down into the two ventricles. And so that's what's happening in A. And then you notice that you see how squished in it is there on this side. That's where the two ventricles are pumping blood. All right, so what we call it is whenever a portion of the heart is contracting, it's called systole. And whenever a portion of the heart is receiving blood, it's called diastole. And it ends up in this first diagram, the atria are in systole and the two ventricles are in diastole. And then over here, where you see the two ventricles squeezing in, they're in systole, while the two atria are filling with blood and they're in diastole. So we have this flip-flopping where we talk about atrial systole, ventricular diastole, followed by atrial diastole, ventricular systole. Say that 3 times in a row. So all it's talking about is what part of the heart is relaxed and what part of the heart is contracting. I think that some of these links, I know the last time I played them may not have worked. Any of these links that you see, you need to watch. I think this is an open heart surgery that may or may not work. It's interesting to see. You can see if it's working. You can see that the heart. The surgeon is just standing there next to somebody who's got their chest opened up, and you can see their heart contracting. But that one may be a dead link now. I'm not sure. I'll have to check. But regardless, any of these links that we have, if they're good, make sure you click on them. Okay, and all right, so I brought in the labeling there. Okay, so what we're talking about is something called the cardiac cycle. And in the cardiac cycle, label A, remember we'd said, that's when the atria are pushing the blood, and the ventricles are filling. So when we talk about atrial systole and ventricular diastole, what we find is that a whole lot of the blood just kind of flows down into the ventricles on its own. And only the last 30% is pushed by the atria down into the ventricles. So you have this sort of passive flow of blood into the ventricles, plus a little bit of a squeeze to push the last 30% down. At this point, since the blood is moving from the two atria down into the two ventricles, those atrioventricular valves are open, right? So the blood is moving, so you don't want to stop it. The blood is moving through those into the ventricles. The ventricles are relaxed, and what's going on in them? Remember, you saw them kind of bulging when the last 30% was pushed down? The pressure will be increasing in the ventricles. So that is atrial systole and ventricular diastole. Now, what do you think we're going to talk about? Atrial diastole, ventricular systole. Okay, so slide 13 is the next step in the process. And we had said the atrioventricular valves, those are the tricuspid and bicuspid between the atria and the ventricles, hence the name atrioventricular. The atrioventricular valves close because we'd said you don't want the blood going the wrong direction. So those valves close, and the chordae tendineae are hanging on for all they're worth to prevent the cusp from being pushed back up. The atria are in a relaxed state. Blood is flowing into them from the superior and inferior vena cava, and also from the pulmonary arteries, or I'm sorry, veins that are bringing blood in from the two lungs. So the atria are filling. The ventricular pressure is really growing, and we have this period of what we call isovolumetric contraction. It's on another slide, but I'm going to mention it here. Isovolumetric contraction. Now, what this is before, as the pressure rises in the ventricles, as they start to squeeze. This is as the pressure rises, it has to get above what? When you have blood pressure taken, you get two numbers, right? You get the systolic and diastolic numbers, right? 120/80. So what that means is you always have some pressure in the artery. So the 80 is the resting pressure in the artery, and this is the pressure that has to be overcome before you get blood ejection, the blood moving into the arteries. So we have this thing we call the isovolumetric pressure builds, and it's because it's growing, but it's 40, 50, 60, and it has to be above 80 before it can push into the artery. And so then it keeps growing, and then all of a sudden you get a period of blood ejection, and that's when the pressure goes 81, 82, 90, 100, 120. That's when the pressure in the arteries are rising, and we have the blood ejection. And so what happened? The semilunar valves open. The ventricle pressure rises until it overcomes the pressure in the arteries. The semilunar valves open, and we get blood ejection into the pulmonary trunk and into the aorta. All right, I'm gonna stop right here. I'm trying to think if I'll probably do one more lecture today. Okay, hang on.